So we're looking at higher order derivatives, which is just as easy as you would think. So the first derivative is what we've been doing, which just means take the derivative, and that tells us the slope of the function or the rate of change of the function, and we can figure out what it is at a particular point. The second derivative, you just take the derivative again, so it's pretty easy. And then you can just keep taking derivatives until the function is all gone, or until it just keeps on getting bigger and uglier. The second derivative is the one that really only matters beyond this point. So the second derivative is the rate of change of the rate of change, or the rate of change of the slope to the function. So not that it matters too much, but I have sort of 4 possible scenarios of functions here. And so you see that this function is decreasing, this function is decreasing, this function is increasing, and this function is increasing. Okay, but where we're going is trying to figure out if the second derivative is positive or negative. All right, so what is happening to slope? Because the second derivative is the rate of change of the rate of change. So let's look at A. So as we move from left to right, what's happening to the slope in A? Is it increasing or decreasing? Okay, let's look at B here. As we change the slope, or sorry, as we move from left to right, what's happening to the slope of the tangent? Is the slope of the tangent increasing or decreasing? Here it goes again. It's increasing or decreasing. All right, same thing with C. Left to right, look at this. Is the slope increasing or decreasing? And D, is the slope increasing or decreasing? Okay. There are 2 of these where the slope is increasing. If you were a guessing person, what would they be? D, the slope is increasing. Correct. Oh, makes a little dinging noise. Okay, yeah. And so the second derivative would be positive. There's a second one where the slope is increasing. So we know D, the slope is increasing. What's the second one where the slope is increasing? Is it A or B or is it C? Yeah, and this one, it's this one, because the slope is going from negative, and ultimately, if we rounded the corner, it would go positive, and so it's A and D, and so the second derivative is positive in these 2. All right, so that's the short answer about what's important about the second derivative. Okay, let's do an easy second derivative. So f of x is equal to 3x cubed plus 2x squared minus x minus 3. Okay, and what we want to do is we want to find the second derivative of that function, which here is symbolized using the prime notation. So let's do the first derivative first. First things first. This is 9x squared plus 4x minus 1, because that's x to the exponent 1, which becomes 1 times x to the exponent 0. But I'm not going to waste time writing x to the exponent 0 like I did right there. And this one disappears because this is negative 3 times x to the exponent 0. So the exponent comes down in front and it turns everything to a 0. So it completely disappears. So there we go. There's the first derivative, second derivative. I just used my power rule, 18x plus 4. Hooray. So you can see if I took the third derivative, it would be 18. And if I took another derivative, it would be gone. Okay, so when we have just these ordinary polynomials with integer exponents, the derivative ultimately disappears. Okay, so let's call this one g at x, just so that they can keep themselves sorted out. So g at x is equal to, let's put this 2x cubed plus the square root of x. Okay, I am going to rewrite this as 2x cubed plus x to the exponent 1/2. So most people don't like fractions, but they don't like radical notation even more, or even less. Like it less, don't like it more. I don't know which of those it is. Sort of a rate of change of the rate of change question. Okay, so we want to find the second derivative. And so let's go through and find the first derivative. This is all just, once again, it's all just power rule. The 3 comes down, 6x squared. This one starts to make our lives a little bit difficult. The 1/2 comes down in front using the power rule. And we subtract 1 from the 1/2, and it becomes x to the negative 1/2. All right, next one. 6x squared, I use my power rule, it becomes 12x plus, this one's starting to cause problems, 1/2 times, the negative 1/2 comes down in front, and we have to subtract 1 from that. So that becomes negative 3/2. Okay, little tidy up phase. 12x minus 1/4. And this is x to the negative 3/2. And so I am actually going to write this in using radical or surd notation. And so there it is, sort of beautified a little bit, if you think that's beautiful. The x is cubed. It's on the bottom of the fraction, and we take the square root of it. Anyways, as you can see, if we went on and took the third derivative, this part would disappear. This part would just continue to get more and more complicated, but it would continue this pattern. We'd actually be able to pick out a pattern. So anyways, that's higher order derivatives. Pretty straightforward at this point. We're not so worried about what the shape of the second derivative is. We do that in a few lessons later on in the course. So, yay, test on Friday. Everybody's looking forward to the test on Friday. So, I'm actually going to ask for proof of the product rule. How many of you forgot about that? At least one. I will ask for one first principles derivative. That's where you do like you do the what do they call that thing? The difference quotient, the limit of the difference quotient, where h goes to 0. It'll be a fairly simple one, like x squared plus 2, or square root of x, or 1 over x plus 2. So it's going to be a fairly simple first principles derivative, and then like 3 questions, you know, like a power rule, a quotient rule, a chain rule question, or some combination. Find the equation of a tangent. That will be the test on Friday. So we have one lesson tomorrow. It's fairly easy. And then we'll have a test on Friday. Any questions, as they would say in France? 9, as they would say in Germany. Okay.